Alrighty, so from 2019 exam 1, we've got question 21. The graph below shows the value in dollars of a compound interest investment after n compounding periods, Vn, for a period of 4 compounding periods. Okay, so here we have it, our compounding periods and our value there. We can see our Vn like that. Okay. All right. The coordinates of where n equals 2 are 2b. So when we look at that, we can see period 0 is starting at $500. Period 1, we have 580. Period 2, we have B. We don't know what B is. Period 3, we have $780.45. Period 4, we have $905.32. The value of B is, okay, how are we going to work this out? So what do we know? We know it's a compound interest investment. Okay, so we know that it's going up by interest. All right, so we need to work out how much interest it's going to earn. So to do that, we need to know the interest rate, and we can easily find it by looking at the difference between these two. Okay, so we can go, well, okay, we've got 580. If I divide it by 500, okay, let's bring up the CAS, oops, 580 divided by 500, approximately equal to force a decimal, equals 1.16. So if I times 580 by 1.16, I should get $672.80, or at least that's what it's closest to. Yeah. Okay. So we can see that is C. I could have also thought about it and thought, okay, it's gone up by $80, hasn't it? It's gone up by $80. So 80 divided by 500, 80 out of 500 is 16%, and it will go up by 16%, so that's 1.16. So again, I apply that to there, so 580 times by 0.16 is $92.80. So 580 plus that amount is $672.80. So whichever way you wanted to think about it, you are going to get that same answer. So 54% of the state answered C, 19% answered A, and 11% answered D. Now, I think, with a lot of students answering A, it goes up $80 again. So I think students got confused there. They saw that it went up $80 the first time, so thought it would go up $80 the second time. And with D, I'm not quite sure what they would have done there, to be honest. Leave that one as a mystery. Okay, let's move on to the next one. So this is from the 2019 Exam 1, question 22. A machine is purchased for $30,000. It makes 24,000 items each year. The value of the machine is depreciated using a unit cost method of depreciation. After 3 years, the value of the machine is $18,480. A rule for the value of the machine after N units is produced, Vn, is, okay, so let's look at this. So, after 3 years, how much has it gone down by? It's started at 30,000. It's gone down to 18,480. So, start a new page. 30,000. Take 18,420. So it's reduced in value by 11,580. Oh, I've typed something wrong there, haven't I? Oh, yes. That's a good thing about CAS. You can look over what you've done and see immediately. Okay, 11,520. All right, so we get told that it produces $24,000 each year. 24,000 items each year. So over the 3 years, it's produced 72,000 items. Okay, so that's how much it's gone down by. That's how many items it's produced. So that depreciation per item is $11,520 per. So that divided by 72,123. Oops. Get our exact value with Control Enter equals 0.16. So that's 16 cents per item. 16 cents per item. So, looking at this, my option here is E, isn't it? Because it starts at 30,000 and goes down by 16 cents per item it produces. E. So 53% of the state answered that one correctly, 17% answered D, and 15% answered C. Okay. I'm not quite sure where they got those from. Maybe you can come up with a suggestion. So here's a extended response question, again from the 2019 exam, from exam 2. This was question 7. Phil is a builder who has purchased a large set of tools. The value of Phil's tools is depreciated using the reducing balance method. The value of the tools in dollars after N years, Vn, can be modelled by the recurrence relation shown below. So V0 equals 60,000 Vn plus 1 equals 0.9 Vn. So use recursion to show that the value of the tools after 2 years, V2, is $48,000. Now, an important thing here to note is that this is a show that question. This is a show that. They know it's $48,600. They're interested in you showing the calculations. Also, they've specified to use recursion. So if you're using a rule, you're not going to get the marks. You have to use recursion. Okay, so let's set this out. We've got our V0 equals 60,000. So my V1 equals 0.9 times by 60,000, which is $54,000. Okay, V1 equals 54,000. V2 equals 0.9 times by 54,000 equals 48,600. Now again, I'm going to stress that they've said to use recursion and they show that. So you have to show those lines. You have to use recursion there. Okay, if you don't, you are not going to get that mark. And we do things like this in the SAC as well. You have to show it. So what is the annual percentage rate of depreciation used by Phil? Okay, let's go back to our rule where we go 0.9 times by Vn. So 1 minus 0.9 equals 0.1. So our rate is 10%. You could have written there the rate of depreciation is 10%. A lot of students, I find, get very confused about, well, where did you get the 0.1 from this? Remember, we're always comparing our rate to 1. Okay, so here it's 1 minus 0.9 because it's less than. So our rate is 10%. Our rate's not 90%, it's 10%. Okay. So Phil plans to replace these tools when their value first falls below 20,000. Okay, so below 20,000. After how many years will Phil replace these tools? Okay. So a couple of things you can do here. When I did this solution, one way I did it was I use a new page again. Was I used my solve, and I could set it up as a rule, thinking through my rule that the tools was 60,000. The rate of depreciation is 0.9, and I'd raise that to the n. And we want that to be equal to 20,000. So equals, oops, I forgot to say I want to solve for n. So n is equal to 10.42. So that would be 11 years. Remembering at 10 years, it wouldn't be below the 20,000 yet. The other way you can do it is to do the recursion. You can go 60,000, oops, yeah, 60,000, and then times by 0.9. So year 1, year 2, 3, 4, 5, 6, 7, 8, 9, 10. So at year 10, we're at $20,920.70 roughly. So you can see we're not yet there. Year 11, there, we're finally under the 20,000. So that's why it is 11 years. So whichever way you choose to do it, either with using the solve or recursion, it is after 11 years. Okay. So that's one to really look at when you're looking for these, that if you're using something like a solve, I'll go back up. Even though this said n equals 10.42, you go, oh, but I would round that to 10. It's like, well, no. At 10 years, it's not below 20,000 yet. It has to fall below 20,000. So that happens at 11 years. That's when we'd do that. Okay, you have to understand that. Okay, so Phil has one other option for depreciation. He can depreciate the value of the tools by a flat rate of 8% of the purchase price per annum. Let Vn be the value of the tools after n years in dollars. Write down a recurrence relation in terms of V0, Vn plus 1 and Vn that could be used to model the value of the tools using this flat rate depreciation. Okay, so first off, 8% of 60,000. Okay, now 10% of that is roughly 6,000, so 8% is going to be less than that. Just start it up again. So 60,000 times by 0.08 is 48,000. Sorry, $4,800. So that means every year it's going to go down by 4,800. So V0 equals 60,000. Vn plus 1 equals Vn minus 4800. Again, you get told to write a recurrence relation. Now, a mistake that the assessors usually point out to us that a lot of students make is they don't read that recurrence relation and they just write a rule, and so they don't get a mark. Even if that rule's correct, because you're asked to write a recurrence relation, you don't get the mark. And notice it says here in terms of V0, Vn plus 1 and Vn. So that's telling you, giving you more clues how to write it and what terms to use. Okay, so next topic is going to be nominal and effective interest rates.